how much helium to put in it, but basically, since we've been doing it a while, we can just kind of see by its size. It takes about 9 minutes or so to fill it. Each of these tanks fills about 4 balloons or something like that.
Oh, is that how it goes? Okay.
So we go through quite a bit of the stuff. And then once the balloon's full, I'll tie it off, turn the gas off, go in there. There's a little room in the back of this little trailer thing with a couple of laptop computers, and that's where we store the little devices that we attach to the balloon and send up in the air with it. And the devices, which you'll see, are little things the size of a... Does anybody use a transistor radio anymore?
I don't know. Ever hear of transistor radios?
Excuse me. Size of an iPod. Know what the conditions are at every single elevation as it goes up.
And what the sound does, this is called a radio sound. And as Dan said, it collects the data and then it transmits it back to the computer. And then what these guys call the bat cave, because it's so tiny and dark in there. This is the antenna here. These are some of the instruments that will record wind speed, humidity, and the GPS and the temperature. And let's see, the balloon goes up about 65,000 feet before it bursts, and then then everything falls right back. And I think we talked about this in your classroom, maybe, that if you go on the ARM website, there's a video where someone attached a camera to one of these, and you can actually see what it's like to go all the way up to 65,000 feet and then come all the way back down to Earth again. Yes?
Do those things break every time?
I don't know if they break or not. The balloon bursts, and then everything falls back to the surface.
But like, with it, they probably do break. Do those things cost a lot of money? Could you do it every single day?
It's a good question, and it's 4 times a day, and that was a concern for a lot of people. These probably cost a couple $100.
It's an expensive project.
And yeah, and the balloon probably costs, I think it was something like $30 or something like that. These are the expensive gadgets. And it is expensive, this whole setup, all the equipment to be here, and I don't know if that includes people's salaries or what, but it's about $8 million for 1 year here. So it is a lot of money, you're right. And so I don't know, it's one of those things you have to consider, the benefits of the data that they're collecting. This information is put in like a big library, like a computer library, digital library for scientists around the world to use to help them figure out what climate change might look like, depending on all the other variables that they input into it.
Like if you had like a normal party balloon, if you let that go, does it go faster or is it as fast as that?
Oh, that's a really good question. And I don't know the answer to that question. He asked if you had a regular party-sized balloon that was filled with helium, and you let that go up into the atmosphere, and one of these arm balloons, which one would go faster?
Probably the arm balloon because it has more helium.
You think the arm balloon because it has more helium?
But that might go higher.
Might go higher.
But not
The
faster.
other one is lighter.
That's a really good... All right, so well, as we're standing here, we'll look around at some more. Some of the instruments that we were looking at when we were up on the top of the hill measure the amount of sunlight that's hitting, the heat, the radiation from the sun. Some of them are shaded and some of them are out in the open sun. They want to take readings from both because they want to, remember we talked about how much sunlight is falling on the planet to keep that energy, the amount of energy in balance. It's kind of like the Goldilocks effect. We don't want it too hot, we don't want it too cold.
Allows the thing, when there's no wind, somehow it needs to have a little wind on it.
It gives a little bit of
It'll wake up the wind sensor.
Oh, that's interesting.
I don't know. Sensor up, but. Okay, we want to make sure it's not tangled up or anything like that. And I think we're ready to go.
All right, you ready? Want to start counting? 10,
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Stop!
Whoa! Let's see.